All right, so we're starting on number 11. Remember, you only need to write down the ones that you got points marked off on. If you got it correct, that's fine. Leave it. I don't need you to write anything down right now. Unless, of course, you think that you got it correct accidentally. That's a different story. If you think you accidentally got it correct, then you should write it down. Number 11, for the most part, you guys did great on. There were a couple common mistakes that I saw. The first one, some people decided to isolate that x first without getting rid of that log. So 3x minus 8 is a part of that logarithm. It is inside of that logarithm. You are not allowed to get rid of anything inside of there until you deal with a logarithm. Most of you guys knew that. You knew you had to deal with a logarithm. I like to call this the wraparound. Start with base 5, wrap around to the 2, equals 3x minus 8. I already hear that you guys have some other... The shroop-de-doop? Perfect, the shroop-de-doop. When I teach pre-calculus, I call this the wraparound. You start with the base. You always start with the base, and you wrap it around to the other side. So when you rewrite this, you should have 5 squared equals 3x minus 8. The reason I like to call it that is because it helps me to remember it. My high school teacher taught me the wraparound. A mistake I saw was that some of you guys switched it. You did 2 to the power of 5 instead of 5 to the power of 2. So make sure you always start with the base and wrap around. So that would be 25 equals 3x minus 8. Add 8 to both sides, we get 33 equals 3x. And divide by 3, so we get x equals 11. Remember, with logarithmic functions, it is important that you check to make sure it works in the equation. So if I plug 11 back in up here, 3 times 11 is 33, minus 8 is 25. That's a positive number, so we're good to go. You're not allowed to have negatives inside of logarithms. All right, questions on 11 before we move to 12. Beautiful. Here's number 12. Number 12. I think I saw maybe 2 or 3 people get this one completely correct. Maybe. Let me tell you the most common mistake I saw. So many people divided both sides by sine of x and got rid of a sign on the left and rid of a sign on the right. When you do that, it completely eliminates one of your answers. So you have to make sure that you manipulate it in a different way. We're not allowed to divide by variables like that. That's a big, big no-no in math. So instead, here's how I want you guys to solve this problem. And like I said, almost every single one of you guys should be writing this down, because there were only a few of you guys that got it correct. Sine squared of x can stay on the left. That other sign that's on the right-hand side of the equation, let's move it over to the same side so that this is equal to 0. So let's move over that sine of x by subtracting it, minus sine of x from both sides. Equals 0. Now, you can kind of treat sine of x as if it's a variable. So, ... Here's our little cloud dream bubble. Does this kind of look like x squared minus x equals 0? All right, it should kind of look like that. X squared minus x equals 0, where sine of x is our variable. How would you solve x squared minus x equals 0? Factor an x out, and then set each factor equal to 0 using the zero product property. We're going to do the same thing over here. We're going to take a sine of x out. That's our GCF, a sine of x. And we're left with sine of x minus 1 equals 0. And again, using the zero product property, we have sine of x equals 0 and sine of x minus 1 equals 0. Those of you guys who divided by sine at the very beginning, you completely eliminated this one. So you did not solve for where sine of x equals 0 because it was no longer part of your problem, but it's still a very important part of the problem. So be careful with that. All right, so my question to you is, do you know where sine of x equals 0? Let's look at our 4 corners. 1 comma 0, 0 comma 1, negative 1 comma 0, and 0 comma negative 1. Sine is which coordinate, x or y? Y. Sine is the y coordinate. So if I'm looking at the y coordinate, I see that it equals 0 here and here, which is what 2 angles? 0 and pi. Good. So the answer to this one over here, sine of x will equal 0 at x equals 0 and x equals pi. So that's 2 of our answers. For the other one, sine of x equaling 1, if I add that 1 to the other side. I want to know where sine of x equals 1. So looking back over here again, sine of x equals 1 here. The y-coordinate is 1 up there. Not the bottom one, because that would be a negative 1, but just the top one. What angle is that? Pi over 2. Good. X equals pi over 2. Now, I'm not 100% sure yet because I've only had judgment from this diagnostic so far. This is a huge, huge, huge thing for you guys to be able to not necessarily solve an equation from start to finish like this, but if I asked you where sine of x equals 0, or like on the next example, if I ask you what cosine of 2 pi over 3 is, I need you guys to know like that, what those answers are. So we might need to work on that a little bit, because from what I could see on the diagnostic, maybe we're not all 100% comfortable with that. I saw a lot of people had to draw it out. I don't want you to draw it out. I think drawing it out takes too much time, especially when you're rushed for time, right? So I'm going to do my best to kind of come alongside you guys and teach you the ways that I want you to start learning these. When I taught pre-calculus, I literally drilled this into my students' heads so much that they just had no questions asked when they came to this class. So we're going to do that with you guys as well to make sure that you guys are very familiar with trig functions, to make sure you have no doubt in your mind about them. We might even have little quizzes to get you guys on board. All right. So hopefully we're good on this one now. Do you guys have any other questions about number 12? Perfect. Let's look at 13. Evaluating cosine of 2 pi over 3. So again, some people went ahead and like drew out a unit circle. But when I have you guys doing stuff like this, I don't want you to draw out the unit circle. So let's try and actually do a little mini lesson on evaluating trig functions. Because if you don't do it this way, I'm going to indoctrinate you to do it this way. Are you ready? So here we go. The first thing you need to understand is where in the world 2 pi over 3 is. So on a scale of thumbs down being I have no idea where 2 pi over 3 is on the unit circle. Thumbs sideways like I kind of maybe could guess where 2 pi over 3 is. And thumbs up being like, yep, I know exactly where 2 pi over 3 is. Show me based on your thumb where your knowledge places on 2 pi over 3 on the unit circle. Okay, good. I see most of you guys at thumbs sideways or thumbs up. So I'll do this as a brief mini lesson. Are you ready? We have 4 quadrants. Quadrant 1, 2, 3, 4. Perfect. Now, I like to think of these as reference angles. I hope you guys all know about reference angles. We have 3 reference angles in each quadrant, and they're all reflected into the other quadrants. What's this first reference angle? Pi over 6. What's this next one? Pi over 4. And what's the third one? Pi over 3. Perfect. If that's 1 pi over 3, the reflection across the way, this one right here, would be 2 pi over 3. All right, that's where 2 pi over 3 is on the unit circle. When I taught pre-calculus, I would teach my students to count them because sometimes it gets a little bit difficult. Always keep in mind where pi is. Here's pi, right? But in terms of over 3, what would this be in terms of over 3? 3 pi over 3. So if you're counting, look. This is at 0 degrees, or 0 radians, I'm sorry. We have 0 pi over 3. Here's 1 pi over 3. Here's 2 pi over 3. 3 pi over 3. 4 pi over 3 would be down here. 5 pi over 3 would be right here. And 6 pi over 3 would take us back to 2 pi again. So literally counting your way around the unit circle to figure out where they are, to figure out what quadrant it's in. All right, so we're good on 2 pi over 3 being in the second quadrant. Is cosine positive or negative in the second quadrant? It is negative. Do you know the acronym to help you remember that? Yeah, all students take calculus. Have you heard that before? All students take calculus. ASTC. All, meaning all of the trig functions are positive. S for students. S meaning that sine and its inverse. What's the inverse of sine? Cosecant. Sine and its did I say inverse? I meant reciprocal. That's my bad. Sine and its reciprocal of cosecant are positive here. Sine and its reciprocal. What do you think the T stands for? Tangent. Tangent and its reciprocal of cotangent are positive in the third quadrant. And what about the C? Cosine. Cosine and its reciprocal, secant, are positive in the fourth quadrant. So cosine is only positive in the first and fourth quadrants. It's negative over here on the other side. So here in the second quadrant, cosine happens to be negative. So that's one of the things I need you to remember. In addition to where the reference angle is, I need you to make sure you know it's negative. Last but not least, all right, and this one is the doozy of them all. You guys might have different ways of remembering them, but this is the way I taught my students to remember it. And I love it because every year they come back and they're like, Ms. Martinez, we were studying at Starbucks and we were doing the left-hand rule. Do you guys know about the left-hand rule? we were doing the left-hand rule and people were looking at us weird, like we were throwing up gang signals. And I was like, no, this is calculus. It's much different. All right. So, and even I've walked into the AP test before and I see students at their desks like this with their left hand trying to understand how to do this. So I'm going to teach you guys the left-hand rule. For you guys out there in computer land, we'll have to learn it some other day because you can't see my visual. But that's okay. Hopefully you guys know the left-hand rule. I'm talking to my second period that's watching the video right now. All right, left-hand rule. Everybody hold up your left hand. Perfect. All right, your pinky finger. Your pinky finger represents 0 radians. Your thumb represents pi over 2. So this is essentially the first quadrant. We okay with that? Yep. All right, your ring finger is pi over 6. Your middle finger is pi over 4. Your pointer finger is pi over 3. We okay with that? Yep. Perfect. Okay. You get to, depending on which reference angle it is. So if we're working with 2 pi over 3, that's the reference angle of pi over 3. So everybody hold down your pi over 3 finger, which is your pointer finger. All right, now here's how it works. All right, I'm going to draw a little picture of a hand up here on the board. I'll even take a picture of it for the people out there in TV land. Don't judge it, please. This is very embarrassing. All right. That's the pinky finger. Ginormous. There's a ring finger so you know the reference. All right, so we're holding down this one right now. That's bent over, all right? That's what it looks like for us. I was going to be an artist. I decided math was the right career, so it's okay. All right. Now, the fingers on top are always going to be cosine. The ones on bottom are always going to be sine fingers, all right? It goes in alphabetical order. The C comes before the S in the alphabet, so the C comes before the S on your hand as well. Cosine's always on top, sine's always on bottom. So far, so good? Yeah. All right? And it's always the square root of the number of fingers over 2. All of them like to be over 2. 1 over 2, radical 2 over 2, radical 3 over 2. They're always over 2. So we're holding up our left hand. We have our pointer finger bent down. In this example, we're looking for cosine. Cosine is the top fingers alphabetically. Cosine comes on top like this. How many fingers are on top of this bent finger? 1. There's 1 finger on top. All right, which means that it's the square root of 1, which is what? 1. The square root of 1 over 2. All right. So this is the square root of 1, which is just 1 over 2. So our answer, -1/2. Now, I know that probably took like 15 minutes to explain that one problem, and you're like, oh, Ms. Martinez, I can do this so much faster a different way. If it works, that's fine, but from what I saw yesterday, it doesn't work for everybody. So I'm going to, like I said, I'm going to indoctrinate you to doing it my way. Well, I'll give you guys little mini quizzes every once in a while, and every single time I'll kind of go alongside you guys and be like, remember, all students take calculus. Is it positive or negative? Which quadrant is it in? Let's hold up our left hands. Let's do this, etc., etc. One little extra trick that we'll cross that bridge when we get there, but I just want to point it out. Tangent, hold up your hand really quick. Tangent, let's hold down the same finger, pi over 3. It's the back of your hand. Tangent is the back, and it's the square root of the top fingers divided by the square root of the bottom finger. So in this case, tangent of pi over 3 is the square root of 3 divided by the square root of 1, which is just square root of 3. All right, so that's how you figure out tangent. We'll practice that, all right? If you're not quite there yet, I saw some of you guys explaining it to your group members, and that's awesome. But we'll get there eventually, all right? We're not there yet, but that's okay. All right, number 14. Write the equation of the function pictured below. There were many options on how you wanted to write this equation. The most common one I saw was vertex form, y equals negative. Some of you guys forgot that negative. Shifted. Which direction was this shifted? To the right. How many units? 1. Is that a +1 or a -1? -1. Don't forget that that squared goes here. A lot of people put the squared here after the x. They put x squared and then -1. That's not where the squared goes. It goes up here. What about vertical? How many units was it shifted up? 4. That's +4. Final answer. Some people forgot the negative. Some people put the squared in the wrong place. Some of you guys decided to write it in standard form, and that's fine if you wanted to put it in standard form. It didn't need to be, though. This one was just as fine. All right, and number 15. This one was supposed to be a really easy problem, but I figured out that you guys didn't know what it was asking you after. A lot of you guys plugged in 3 to all of them and just put that as your answer. But let's look at this as a picture rather than an equation. Are you ready? Let's graph this together. So I want you guys to graph it on your paper as well. It says f of x equals x squared when x is greater than 2. When I have my students graph piecewise functions, I literally have them graph the whole thing really, really lightly and then just erase the part they don't need. So I'm going to graph the entire graph of x squared. And then I only want to keep that graph where x is greater than 3. I'm sorry, greater than 2. So I'm going to erase everything else. So I don't want it anywhere over here. All right, that's x squared when x is greater than 2. The next one, when x equals 2, the function equals x, y equals x. Where's that point? Because that's just a point, right? X equals 2 is just a point. What is it at? 2 comma what? Do you know what the line y equals x looks like? It looks like this, right? So if it's just the point at x equals 2, then the line x would literally just be the point 2 comma 2. So I'm going to erase everything else. I just want that point 2 comma 2. Once you get better at it, by the way, you don't have to erase it every single time, but it helps in the meantime. So there's that point, 2 comma 2. And last but not least, it's x to the negative 1 when x is less than 2. Do you remember what x to the negative 1 is? How do I rewrite that without a negative exponent? 1 over x. That's a rational function. It looks like this. All right, and it gets cut off right there when x is less than 2. Looks like that. So that's what this piecewise function looks like. Not very pretty, but that's a piecewise function. Now, if I'm evaluating at f equals 3, or f of 3, I'm sorry, here's f equals 1, or x equals 1. Here's x equals 2. Here's x equals 3 way, way over here. Does x equals 3 touch the rational function? Does x equals 3 touch this point right here? No, x equals 3 is eventually going to touch this quadratic function. So when I'm evaluating f of 3, the only thing I care about, literally the only thing I care about, is what part of the domain it's in, and then plug it into that function. So 3 is greater than 2, which means this is the piece of the piecewise function that I'm evaluating it at. And I'm going to plug in 3 here. What's 3 squared? 9. That was the answer to this question. F of 3 is 9. All right. We get out of here at 10:18, which is going to bring in like 30 seconds. So